Okay, we're doing problem 6 of exam 2. So this one, they want us to find the position of the graph, position of the particle at s equals 2, s of t, and they want us to find for part A, find the first and second derivative. So first we want to know where s of t is, which is this function, which is t cubed minus 12t squared plus 36t. Now we just want to solve for f prime t, which is going to just use the product rule. No, not the product rule, the power rule, which is give us this. Now we just have to do it one more time, which is 6t minus 24, and that'll be it. Easy. Now, let me lock this real quick. Okay. If the first derivative is the velocity equation, when does the particle rest? So, first, okay, so we want to know where the velocity equation is at rest. So we want to know where this is at rest, we need to know v of t equals 0. So let's figure out where v of t is. Since 3t minus 24t plus 36. I don't know what happened here, but let's rewrite this. You want to know that equals 0. We can factor a 3, so we can do t squared minus 8t plus 12 equals 0. From this, we can take it out even more. 3 of t minus 6 of t minus 2 equals 0. So we know t equals 6 and t equals 2. So the particle is at rest at 2 minutes and 6 minutes. Okay. Let's do C now. Algebraically determine the intervals where s of t is increasing. Okay, so this is pretty easy. What we want to know is the velocity of 1, 4, and 7. Since we know where at rest is, since it's going to be at 0, 2, and 6. Okay, so v of 1 is going to go here, v of 7 is going to go there, and oh, this is v of 4. V of 1, there we go. That's all we want to figure out. Since v of 1 is going to be positive, negative, negative, since we can see from this function 3 of 1 minus 6 of 1 minus 2, which is going to be a positive minus minus, which is going to lead us to a positive function. We can now do the same thing with the other one. F4. 3 of 4 minus 6 of 4 minus 2. So this is also going to be a positive, positive, negative, which is going to be negative. Since 4 minus 6, that negative 2 is going to overrule everything. Now we can do the final one. Since 7 is going to be greater than everything, this is going to be positive. So we know where the intervals is now. So then increasing at 0, 2, union 6 to infinity. Okay. Now we want to know where the particle moves west. So all we want to know is where acceleration is. Okay, so on the interval, the particle moving west. West means where it's negative. Since from this we can tell where negative is, so we can tell it's particle moving west at 2, 6. Since west means negative. As we can see in the chart here, west, east, never eat soggy waffles. West is going to be negative since on the first, this is on the third one, 2, since on the second quadrant, since negative, negative, positive, positive, and this is negative, positive. There you go. Yeah. Okay. Now we want to do on E. On what intervals of time does the particle have a negative acceleration? So to find this negative acceleration, we want to know what a of t is, which is going to be 6t minus 24, which can be factored out as 6t minus 4. And then we can solve for 0, which looks like t equals 4. So we can do another quick short at 0, 4. Since it's time can always start at 0. It can't be negative time. And then we want to find where it's negative. So let's do negative 1. Let's do 1. 6 of 1 minus 4. It's going to go 6 of negative 3, which is going to be negative. So the interval has a negative at 0, 4. Okay. Now we want to do this one. Use information from A to E to determine the intervals when slowing down. So we want to know where V of t is, since we know it's from 2, 6, positive, negative, positive, and we know the velocity from 4 to 0 is negative. So from here, we know that particle is slowing down wants opposite signs. Opposite signs means 0, 2, since it's positive, negative, and from 4 to infinity, 4 to 6, since this is opposite signs. Since if we do this, if we go back here to acceleration and put 5 in, a of 5, this would give us positive. So that's 6 of 1 equals positive. So it would be 4 to 0. So slowing down at 0, 2, union 4 to 6. Okay, and then let's do the bonus one real quick. So for the bonus, we want to know where the total distance is for the function. So the total distance is s of 2, half the value of s of 0, plus of s of 6 minus s of 2, which will give us 48. All we have to do is just go back to the regular function of distance and just plug these in. Okay, thank you.